Y equals x squared looks like this. Y equals 2x plus 3, that's got a y-intercept of 3. So if we say that's 3, it goes up by 2 into the right one. That's a rough sketch of the graph. And eventually that line crosses. And we're supposed to find the volume in the region bounded by these curves. Rotated around the x-axis. I think we were asked to use the washer method too, based on the place we are in the text. So what that means is we want to construct the equation for two circles. We want to find out the equation of a circle that's made at any point. Let me change the color. Here, when it's revolved around the x-axis, or a circle here, or a circle here. We want to create an equation for all those possible circles. And then we're going to subtract it by the equation of a circle that's made bound by this region. And then we integrate those to bring the circle, a two-dimensional object, into the third dimension so that we can find volume. So any circle that's drawn with those red lines as the radius, from here to here would be the radius. That's defined by this part of the curve, right? The straight line that I tried to draw. So that's our radius. And the area of a circle is pi times that radius, which is 2x plus 3, and then we need to square the radius. Okay, so that's the volume of the region revolved around the x-axis, where y equals 2x plus 3 is the only thing considered. We need to subtract this volume, though, when this region is revolved around the x-axis. That way we have the region just in between the curves like they asked. So the radius of that other region is going to be x squared. And then to find the area, we square the radius. The last thing we need is just the limits of integration. We need to find out where these two curves cross. So you'd set the two curves equal to each other and solve. So if I get that equal to 0, oops. And then if I factor x minus 3 and x plus 1, I found two numbers that multiply to be negative 3 but have to be negative 2. So we get x equals negative 1 and x equals 3. So those are our limits of integration. And there you go. So that's the toughest part of the problem. The rest of this is just calculus. I mean, factor out the pi, because you got a pi in both terms. And so you'd want to square this parentheses, so multiply the two parentheses together, and then combine like terms, and then you can integrate term by term there. You'll have an x to the fourth term, so that'll be x to the fifth times 1/5. Let's see what else you can have. There's some more algebra involved there, but the hardest part's done. That's the integral. But you can let me know if you have trouble with the integral.